If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where you are building concepts on differentiability. So in this lecture we will see different graphs on the basis of which we can say the function is not differentiable, and we will try to visualize it, and we will see some basic theorems in differentiability. Okay, then let's see this. Okay, so in the differentiability for intermediate and advanced portion, let's understand graphically what does differentiation means, or what does a function not differentiable means to us. A function fx fails to be differentiable at a point x equal to a if there are three conditions. In these three conditions it may fail to be differentiable. First, it is not continuous, that we have seen, like your box function. So suppose we are calculating differentiation, doing differentiation at x equal to 2, but x equal to 2 it is not continuous because 2 plus is 2, 2 minus is 1. So that's why due to discontinuity differentiation is not possible. So we cannot do differentiation at x equal to 2. So this is first case, that is easy. Second, the graph of fx changes its direction abruptly at x equal to a. That is, there is a sudden change in the direction of the graph. In other words, it has no unit tangent because it has a sudden change. In the right side you will find one slope, in the left side you will find another slope. That is also known as sharp turn. There is a sharp turning there, because of which your LSD and RSD are not equal. The second one, LSD, RSD, if they are equal means you have a unit tangent. So there is a smooth turn. But if there is a sharp turn, then your LSD, RSD will be different. You can see one example, fx equal to mod x suppose. So mod x we can break it. For x greater than 0 or equal to 0 it is x, for less than 0 it is minus x. Equal to also give, you can give equal to here or here anywhere. Okay, because at 0 it is 0, 0 plus minus doesn't make any sense. So this is the graph. Now you can see there is a sharp turn, due to which if you want to take differentiation at 0 it will not be differentiable. You can check, if you do LSD, left hand derivative, if you take differentiation of this one, what is differentiation of LSD? LSD means less than 0, that means this one. What is the differentiation of this one? Those who have done already differentiation, you know, minus x differentiation is minus 1. And what is the differentiation of x? Because I am considering right hand derivative, 0 plus means I will take this function, differentiation is x. You can see LSD, RSD is not same. From LSD the tangent is this, from RSD the tangent is this at this point. If you move little bit here, your tangent will look like this. If you move little bit left side, your tangent is look like. So there are two different tangents, they are not unit tangent at this point. So that's why it is not differentiable at x equal to 0. The function is continuous, although it was continuous, it is continuous function because we are drawing in a single stroke. There is no discontinuity. 0 plus is also 0, 0 minus is also 0. Value of the function. But it is not differentiable. Due to sharp turn, it is not differentiable at x. And the third case is f, the function y equal to fx has a vertical tangent. Vertical tangent is you have LSD, RSD both are equal, but they are not finite, infinite. So infinite also limit does not exist, so that is the case. So you can say your LSD, RSD, they are going to infinite. So as a vertical tangent at x equal to, that means fs is continuous at x equal to a, there is no problem continuity, but LSD, RSD, they are going towards infinity. That also comes under limit does not exist. That means we say limit d and e does not exist at x equal to a. You can see this graph. One example I have taken, just a waveform I have taken abruptly. At this point, if you take tangent, if you go little bit, it will be just a straight line. Tangent will be this one. So tan 90, slope of this one is infinite. The slope of this one is this is very straight, infinite slope. So that means at this point differentiation does not exist because it is going towards infinity. So that is also one case of discontinuity. In the graphical we can say. Now what is differentiability of derivability? Derivability is derivable, that is differentiable over an interval, like your continuity over an interval. Suppose a function is continuous in between these two, we have already seen. That what was the definition of continuous? It should be continuous at every point in between these two, and at the boundary point A, because you don't know the left side of A. So at A it should be right continuous. At B, because you don't know the right side of B, because we are stopping at B, so it should be left continuous at B. Similarly here, it will be derivable in this interval AB if for the point AB, because you don't know the left side of A, because you are starting from A. So at A it should be right hand derivative, it should exist, it should be right hand derivative. At B you don't know the right side, you have left side because you are going up to B only. So at B it should be left hand derivative. These two should exist, A and B. And in between them any point C, the both LSD, RSD should be equal. That means it should be differentiable at between every point. But at these extreme points, this point it should be right hand derivative should exist, and this point left hand derivative should exist. like your limit. In this case it was left hand right hand continuity, at this case it was left hand continuity. Suppose f g are the derivable at x equal to a, then f plus g, f minus g, f into g, f by g, but provided g should not be 0, they will be all derivable at x equal to a. If both are derivable at x equal to the product sum into divide, you have to be careful, this one cannot be 0, otherwise there is no definition of function, it will go to infinity. Now your f is differentiable, g is not differentiable at x equal to a, but their product can be still differentiable. If you see fx x, this is differentiable, but this one just now we have seen mod x is not differentiable at x equal to 0, but their product is differentiable, because if you split your fx into two parts, this f into g, if I name it hx, if you write hx in split, so x into x, that is x square if x is greater than 0, because for greater than 0 there is no need of mod, for less than 0 you will put minus x, so minus x into x, that is minus x square. Now you do LSD RSD, LSD is left hand derivative 0 minus, it will be minus 2x, in place of x you will put 0, so it is 0. RSD at 0, again 2x, in place of x you will put 0 plus, so again 0. So you can see LSD RSD are equal. So it is differentiable at x0. So you have to be careful. It is not that one is not differentiable, that means product will not be differentiable. Similarly, fg both are not differentiable, then also fg can be differentiable like this. If you do this one, it will be same x square. If you take product of these two f and g, it will be mod x into mod x. Mod x whole square means no need of writing mod, because square will also take it. So it is simply x square. So this is continuous. This is differentiable, because every time you will get 2x. Fg both can be, their product can be differentiable, so you have to be careful. Similarly, f plus g also can be differentiable. So as you can see, this is not differentiable at x equal to 0, this is not differentiable at x equal to 0. But if you add these two, f plus g, they will cancel it out 0. So 0 is a function which is differentiable. It is constant. If you take differentiation, it is 0. Left and right hand both will be 0. So you have to be careful. It is not that both are not differentiable, then sum is not differentiable, product is not differentiable. You have to see what is the function that is forming and check whether that is differentiable or not differentiable. If you like the video, then press the like button and please give your valuable comments in the comment section.